Alright guys, this video is about isotopes and ions. So we're going to start by first talking about isotopes. And isotopes are different versions or different variations of the same element that have a different mass. And if you remember, the mass is only accounted from by those nucleonic particles, protons and neutrons. And if you change the protons, you actually change what element you're talking about. For instance, if I had hydrogen, which has one proton, and I added one, now I don't have hydrogen anymore, now I have helium. So the protons have to stay the same, which means the change in our mass, our different mass from our different variations, has to come from a different number of neutrons. And so that's what's going to change in your different isotopes. So we may have talked in class, or you may have read it in a book somewhere, about different isotopes of carbon, like carbon-12, carbon-14. We're going to talk in this video about nitrogen. So the two naturally occurring isotopes of nitrogen are nitrogen-14, which is the most abundant, and nitrogen-15, which is not as abundant in nature. So we're going to look on our periodic table at nitrogen. And we see that the average atomic mass of nitrogen, I don't know if y'all can read that, it's 14.00674. So it's very, very close to 14. And we also see that nitrogen has an atomic number of 7. So that means we for sure know it has 7 protons. No matter what, any version of nitrogen has to have 7 protons. But in this one, its mass is 14 AMU. So in order to get to 14 with my protons plus my neutrons, 7 plus 7 is going to give me my nitrogen-14. Over here, in order to get my mass of 15 AMU, 7 protons plus 8 neutrons, and I'm going to put n to the 0 power or n naught to show that it's neutral, doesn't have a charge. That would be my nucleus here. And so that's how they're different. They're both probably going to have 7 electrons to be neutral, but this one is heavier. It's the heavier isotope, and it's less common because when we average all the ones found in nature, we get, like I said, 14.00674. That's the average atomic mass of all of these naturally occurring particles. So there's a lot more of these averaged in than there is of these, which is why this number is so much closer to 14 instead of 15. So that's isotopes. There's lots of different isotopes, but the word isotopes just means different versions of the same atomic element. That's really all it means. There's something called isotope notation, where you put the element symbol, you put the atomic number down here, which is your protons. So these are both in with a 7 down there. And then you put its mass at the top. So this would be the isotope notation for nitrogen-14. And this would be the isotope notation for nitrogen-15. A lot of times we'll just write it out like this, or we may even write N-14 or N-15. Those are all just different ways of saying the same thing. All right, the next word we're going to talk about today is ion. And ions are atoms that have a net positive or a net negative charge, meaning overall the atom is not balanced as far as positives and negatives go. Positive ions are called cations, and negative ions are called anions. And so we're going to talk about 3 common ions. So we have chlorine. This is Cl minus. In other words, it has 1 negative. It's a charge of -1. So if you look at chlorine on your periodic table, you'll see its atomic number is 17, which means you are talking about 17 protons. No matter what, has to have 17 protons to be chlorine. And if we're just talking about regular old chlorine, then it has a mass of 35, so it's got 18 neutrons most likely, and 17 electrons would balance it out. But this is not regular chlorine. This is chlorine with a negative charge. And the reason that is because these 17 electrons are going to fill up the first energy level with 2 electrons, the second energy level with 8 electrons, the third energy level with 7 electrons. 2, 8, that's full. 7 is almost full. It needs one more electron to get a full octet, and so it wants one more. It wants another electron to make a full outer valence energy shell. So that would be 288, which adds up to 18 electrons. And so now you'll see if it has 18 electrons, it's got one more negative than it does positive. So you end up with a balance of -1, which is how you get this negative chlorine ion. All right, let's do magnesium. This says magnesium 2+. So magnesium on our periodic table is atomic number 12. So it has 12 protons. It has a mass of 24, so it has 12 neutrons. And if it was regular neutral magnesium, not 2+, it would have 12 electrons. But those 12 electrons are going to go on their energy shells like this. Level 1, level 2, level 3. 2 electrons fit on the first energy shell. 8 electrons fit on the next energy level. And then to get your 12, so this is 10 so far, we would have 2 more. Well, the third energy level holds 8. It doesn't want just 2 electrons on it. It wants to either be full 8, which means we would need to find 6 more electrons, or we can lose these 2, get rid of them, which makes this our valence shell. So now we only have 10 electrons. We have a full octet on our outer shell now. And then you can look at your protons and electrons and see, oh, I have 2 more protons than electrons, which is how I get this 2 positive or +2 charge. So that's not neutral, it's positively charged. That would be a cation. All right, if you would like to pause the video, I suggest you do so and try to do potassium. This is a potassium with a +1 charge. So it has 19 protons. It has a mass of 39, so that's 20 neutrons most likely. And if it was neutral, it would have 19 electrons. But those 19 electrons would be 2 on the first shell, 8 on the second shell, 8 on the third shell. Now we're at 18 total electrons. We need one more to make 19, and that would be on the fourth energy level. It definitely doesn't want that one lonely electron out there by itself on the fourth energy level. So the easiest thing to do to get its full octet would be to lose 1 electron. Now we have a full valence shell on the third level. So this becomes 18 electrons. And you can see now we have 1 more proton than electrons. So that's what makes this a +1 charge. All right, that's the end of this video on isotopes and ions.